Looking forward to our next speaker, during which I'm going to have a nap. That's not true, Sandy. I won't do that. That's a lie. I have seen Sandy speak many times, and on the occasions where I've spoken before or after, I always publicly admit that I still haven't read her book. But today, I want to tell you something. I haven't read her book yet, and I still feel bad about today because I haven't yet to hear a person that hasn't read that book and said that it hasn't affected their life, professional life, and perhaps their spiritual life in some way because of the ideas in it. Sandi is an exceptional speaker, and I really would like you to put your hands together for Sandi Metz.
So wait, do this.
You're breaking mine.
So Dr. Nick told me not to tell him any secrets because he said he would steal them and tell you. And I have to tell you that he stole my nap joke. Stole it. And I know we're running a little behind schedule, and my talk goes exactly 30 minutes, so I'm going to use just a minute before I start to tell you that I feel completely unsympathetic if you're used to having a nap after lunch and now you're here, because I am missing the Vuelta, the 3-week bike tour in Spain, which some of you may be familiar with. An American, Chris Horner, took the lead yesterday in a dramatic finish. Today is the final day, and they're riding right now. I want you to appreciate I'm here with you instead of in the front of the TV. You're welcome. So, rules. What a great title for a talk, right? We love rules. In this talk, I'm going to give you 5 rules about how to write object-oriented code. Following these rules will improve your code. The rules are important, so you should always follow them. And they're completely arbitrary, so it's perfectly okay to break them. And while I was preparing this talk, I read a bunch of research about rules and rule following in humans and why we follow rules, even when we would not otherwise, even when no one is going to bust us and we would not otherwise be harmed by disobeying them. And I found some really interesting research, at least it was interesting to me, about rule following, which I think is even more important than the rules I'm going to give you today. And so this talk is in 3 parts. At first, I'm going to just talk a little bit about rules, what rules are and how social scientists define them. And then we're going to switch to the technical part, and I'm going to give you 5 rules for writing code. I'm going to tell you how to write object-oriented code. And at the end, we're going to go and do a little meta talk about rules, which is going to give you an even more important reason to have rules. Okay, so first, what social scientists think of rules? They think of rules as falling into one of 3 categories. There are taboos. Taboos are things that are forbidden. We think of them as unclean or cursed, and they usually involve breaking a taboo, usually involves some form of supernatural punishment. Incest is a taboo, and so is cannibalism. Oddly enough, there are no universal taboos. There is not any one single prohibited thing that is uniform across all cultures. Next, after taboos, there are laws. Laws are rules that govern behavior that are enforced by social institutions, which are not always rational. There are criminal laws where the state decides they're trying to maintain whatever they think of as social order. And there are also civil laws where the state adjudicates between 2 people who are having a dispute. And finally, after laws, there are customs, or what social scientists call norms. Norms are group-held beliefs about how members should behave in a certain context. And an example of a group norm is that kissing thing that people do when they greet. This is a police station in France where they're changing shifts. This would be absolutely abnormal in America, but it would probably be abnormal not to do this in France. It's clear to me that I do not look Spanish because everyone who greets me either gives me a hug or shakes my hand. And last night I had to ask the guys as we were leaving the dinner if they would be given cheek kisses if I were Spanish, and they said yes, and so they taught me how. So I got to practice that last night, which was very cool. So taboos, laws, and norms, many of them are both arbitrary and unenforceable. And so the really interesting question about rules is why we obey them. And social scientists, the people who study something they call social rule system theory, they traditionally give 8 possible reasons to explain why someone might follow a rule. And the research I'm going to talk about in part 3 suggests a 9th, which again, I think is the most important reason. But first of all, here are the first 8. Self-interest. You might follow a rule because you gain something to achieve a gain or to avoid a loss. We want to win the trophy, and so we follow the rule. Next, you might follow rules because you want to mark yourself as part of a group. The French police people might think of themselves as the really polite group who greets by kissing on the cheek. And we might think of ourselves as the group that never leaves trailing white space. There are all kinds of ways for groups to identify themselves, and regardless of how informal the rules are, they delineate the group, and we use them to recognize each other. All you have to do is look at that picture, and you know it's us. They're marked as identity. They follow the rules. Now, next, you might follow a rule because it's given to you by an authority. There are obviously religious authorities. This is the Pope in Barcelona a couple years ago. But there are secular authorities. There's no law that says you're out, but you go back to the dugout regardless. Groups promote authorities, and then they respect the rules that they create. Fourth, people follow rules because we have a sense of order. People love order. We follow rules that are otherwise meaningless because they make the world seem regular and dependable. We know the right distance apart to stand at the bus stop. And it bothers us when people violate that rule, even when it does not otherwise harm us. Next, there are social sanctions, the most obvious being prison. But some rules have such built-in sanctions that we tend to follow them even when there's not a law prohibiting them. Some rules we follow because of what they call the veil of ignorance. We follow these rules even when we are harmed by doing so because we don't understand the consequences. Imagine that you have a rule, accept all free things. This can turn out badly. And finally, you might follow a rule out of simple habit. We like to think of ourselves as self-aware, but there are many ways in which we're programmed by our experiences and our cultures, and the most deeply accepted rules are often the least questioned. So there you go, that's rules. Taboos, laws, and norms. And we follow them for all kinds of reasons, even when it's against our own self-interest. And so against that overview of rules, I'm going to give you 5. These are rules about how to write object-oriented code. Now, these rules are norms. They are not laws. And even though sometimes we treat our rules as taboos, these are not chiseled in stone. And so each of the rules is actually a constraint. It's a limitation on behavior. The first rule, my first rule when writing object-oriented code is that a class may contain no more than 100 lines of code. The second rule is that a method may contain no more than 5. And the third rule is that you may pass no more than 4 parameters to a method. I have always regretted this rule. Feels like maybe it ought to be 3. Somewhere between 3 and 4. 4, if you have to pass 4 parameters, there's definitely an object in there. Oh, and the corollary to this rule is you cannot just cheat with a hash. Right? Don't even. All right, so those first 3 rules, 100 lines in a class, 5 lines in a method, 4 parameters passed to a method, they're strictly about writing plain old Ruby code. The next 2 rules are about writing Rails code. A controller action may pass only 1 instance variable to a view, and a controller action may know only 2 other class names. Now, some of you probably may have heard me give this set of rules on the Ruby Rogues and a Ruby Rogues podcast early in the spring, and I misspoke on that podcast, and I said 1 here, that a controller action could know 1 class. What I meant was that it could know 1 business class and 1 presenter class. Many people who heard that podcast adopted that rule, and I can tell you it works perfectly fine. And so just like maybe 4 parameters should be 3, maybe 2 classes should be 1. The constraints clearly work if they're tighter. And then, of course, I gave 1 final rule, and it's a rule about breaking the rules. So you can break any rule you want, as long as you can talk someone into believing it's a good idea. All right, so here they are. 5 simple rules. They're incredibly easy. They're easy to remember, and they're easy to implement. The rules aren't complicated, but following them has enormous consequences. Imagine the app that was created by these rules. They force you to create small objects, and they bias those small objects toward POROs, toward plain old Ruby objects. You can't write objects that are bound up inside the framework you're using. The rules force each of the objects that you create to know a minimal number of other things. And so objects end up with very few dependencies. We don't know what the future holds, but we'd like our apps to survive it. And following these rules will help. They make changeable apps that are built of small objects that require little context and have few dependencies. They're simple, straightforward, well-tested code that can easily be reused in novel and unexpected circumstances. Sorry. So the rules themselves, they're not that special. And in some ways, they are completely arbitrary. I cannot make a case that says 101 is substantially worse than 100, or that 99 is substantially better. These are just a line in the sand. They're a mark that says, come here and go no further. This is the place where you have to ask the question, should I break this thing in half? What responsibility can I chisel off into another object? The rules are a means to an end, and that end is to reduce the cost of software. If you define cost as time, money, or pain, then what we want is to produce features at the lowest cost. And I assert that the best way to do this is to make small objects. And I assert that the best way to do that is to define what small means, to make a rule about small, and then follow that rule. So the rules are to achieve a goal, and achieving the goal is far more important than the rules. We're not bound to these rules, we're bound to the goal, and we will adopt any rule that lets us achieve that goal. So I think I'm right? I think small objects will reduce your costs. But I am absolutely willing to admit that small objects have a price. There's a cost of their own. This is a design choice, and like every design choice, it has consequences. Following these rules places a bet that you'll be better off making many small objects than you will be making a few large ones. It's choosing between objects and procedures. I thought it was interesting that Matt said this morning that the scripts were 100 lines long, and that's a procedure, right? And which is kind of my limit on the size of a class. It's bad for me to stray from my script. So ask me more questions about that if you want to hear about it later. So think about this. Imagine your application as on a continuum. On one side, you can have a few really large objects, long step-by-step procedures that have all the code in them. At the other end of the continuum, there's an application made of many small interacting objects. On the very big, the list of long procedures, they are really easy to understand. You can look at that code and tell exactly what's going on. However, if it's hard to change, it's easy to break something else if you make a change inside a long procedure, and it's very difficult to reuse part of it. You end up having to copy and paste, and then you have to worry about what state that stuff relied on. And so the upside is it's really easy to understand when you first look at it. The downside is that it's almost impossible to change. If your app never changes, that's a good bet, but most of our apps do. On the other side of the continuum, you have this notion of a big pool of small objects, and those small objects are clearly more difficult to initially understand. Looking at the source code of a bunch of small classes does not tell you everything. Much of the logic in that app exists in the messages, and the messages don't actually happen until you reconstitute it all and put it in memory. And so when you're looking at the source code for a bunch of small objects, you have to construct an imaginary mental model and supply the messages yourself in order to understand what's going on. Messages are at the core of object-oriented design. They create seams that give you levels of indirection, and they let you define objects that play roles and then use the roles as shields so that you can substitute new objects behind them. Messages are what gives you changeability. And so we have this tension between an app that contains a bunch of procedures where you can look at the source code and be comforted because you can understand what it's doing, and another app that has a bunch of small objects where you cannot immediately tell the operation of the whole by looking at the individual parts of source code on disk. And I want to tell you two stories. When I was at RailsConf this spring, I had a conversation with a young man who had read the book. He'd written a couple of object-oriented apps, but they were mostly collections of long procedures. And he was trying to follow the pattern of creating applications that had a bunch of small objects. And he tried to ask me a question that I had a very difficult time understanding. So we spent a long time in the hall sort of banging heads trying to get it right. And finally, I understood his question to be this. He said, I used to write procedures, and now I'm creating lots and lots of small objects. When will I understand my new app in the same way that I understood the old? And when I finally understood that to be his question, I had to look at him and say, never. You're never going to understand this new app in the same way that you understood the old. It's not as if having a bunch of big procedures and having a bunch of small objects are two arcing paths that lead to the same endpoint. They go different places. So what I told him was that you will never understand it like you used to. What will happen is that you will cease to care. It will quit bothering you after a while. And to illustrate why, I'm going to tell you one more story. Caleb, who's here somewhere, who works for Thoughtbot in Boston, Mass. In the U.S., was part of a group of people. When I first discussed these rules in the spring, he took them into Thoughtbot, which is a consulting company, and they decided to adopt them on a project they were working on and use them exclusively as a test, as an experiment to see if they would help. And they spent a while on that new project, and I had a conversation with them last week to sort of check in to see how they would evaluate that experience. And what they told me was that they loved it. Even though the experiment had ended, they continued to use the rules on that project, and that people who had been on that team that left and went to other projects took the rules with them. They found them very useful as a way to write code. But I specifically asked them about this issue, about the tension between understanding a few large objects versus a bunch of small ones. And I was particularly worried about and interested in the experience of junior programmers, how they dealt with that pool of small objects. And so when I asked that question, they turned the camera around and pointed it at a young man named Paul. And I asked Paul, how does it feel working on this application that's built of a bunch of small things? And what he said was that he loved it, because it made him feel safe, that he knew that he did not have to understand the entire application to make a change. He just needed to understand his part, and he had no fear. He had absolute confidence that if he understood the part he was changing, he could make that change without breaking something in the larger whole. And that's the power of small objects. It really worked for those guys. And so making this choice, going more towards small objects, requires a change in perspective. And many of us think of our applications as Rails apps. And Rails has an opinion about how to organize code, and that opinion is tremendously helpful. It's at the root of Rails' success. For those of you who are old enough to remember there was a video many years ago about make a blog in 10 minutes. That we all watched that brought many of us to Rails. And it was a feat of technology. And in that, you may remember, there was a controller that knew the name of one class, post, and it used that class to create a single instance variable at post to pass to its view. That's the Rails pattern. And that application was the classic Rails app. It was a wrapper around a database that let you do CRUD operations, right? Create, replace, update, delete operations against a pile of data. The edges of the framework, the incoming message and the outgoing persistence were stuck together. They were glued right in the middle. There wasn't any domain logic in that app. And if this is the problem you have, you should use the Rails pattern to solve it. It's exactly right. Put all of your code in subclasses of application controller and active record base. That's the perfect solution to that problem. However, some of us have more complicated apps. They're not really Rails apps. They're apps that use Rails. An application that uses Rails is one that has a bunch of business logic that does not map directly to an action in a controller or to a row in a database table. And when you have that, if I want to follow the pattern of how Rails expects me to behave, and I have a bunch of business logic that doesn't fit into that, in order to use the Rails pattern, I have to push the edges of the framework apart and create new objects of my own and put them in the middle. And the 5 rules force you to do that. That's the way to do it. Shove the edges of the framework apart and make small poros with few dependencies. Create your own objects that have your business logic and put them in the middle. And so if I'm right, you should follow these rules. Not because I'm an authority, or not because you want to identify with this group, or not because they meet your sense of order, but because it's in your own self-interest. I think they save money in your application, but it turns out that there's more to it than that rules have more value than just saving money in your application. And now we're to part 3 of this talk, the meta part about rules. It turns out that rule following is a thing we humans do to send signals to one another. And there's some interesting research. I have a psychology degree, so I'm a recovering psychology student. I read a lot of research. There's new research that I think applies directly to our business of writing software applications. It's by these 2 guys. I can pronounce one of their names, Kimbra, and that other guy. And here's the name of the study, which, like every academic study, is impossible to parse, so let me just do that. This is their assertion that rules screen for cooperative types. And I'm going to tell you about the study. It has 2 parts. In the first study, they divided subjects into groups of 8, and they wanted to figure out, in that group of 8, which were more rule-following and which were more rule-breaking. And so they had them play this game. The goal here is to walk across through all these stoplights. You press this button to make the little person walk. When they walk to the next red light. You start out with €8. You lose 8 cents a second while you wait. Every red light lasts 5 seconds, and your instructions are the rule. This is what they tell the subjects. The rule is to wait at each stoplight until it turns green. All right, so it takes 4 seconds to walk from light to light and then across the end. And it also does, lights obviously wait 5 seconds. So if you obey the rule, the most you can keep of your €8 is 4. If you ignore the rule, you get to keep 6. You'll have more money left at the end if you ignore the rule. And so some folks play the game like this. They go to the first light, they wait for 5 seconds, it turns green, they press the little walk button, the little person walks, they wait. Okay, so, right? You get the idea here. Then some other people play the game like this. They just put their thumb on the walk button, because it turns out the walk button works even if the light's red. You won't know that unless you run this experiment. Okay, so this is the test they use to separate rule followers from rule breakers. And I can hear all of you thinking that you would be a rule breaker, because you're programmers and you're game players and you want to know if the walk button works and you would press it. You would try. So let me give you a different instruction. Let's use this as our instruction to decide if you're a rule follower or a rule breaker. Go to the first stoplight, make this change in the source code, and then check it into the source code repository after removing all the trailing white space, and then press walk. Yeah, you don't feel like so much of a rule breaker now, do you? Yeah, so the test is context dependent. So imagine that you get put in a group based on that test, a test that's context dependent for us. And so after they did that, with every individual person, they took the 4 most rule-following people and the 4 most rule-breaking people in every group, and they separate them into teams. And they had the teams play a cooperative game. Here's how the game goes. There's 4 players. They play 10 rounds. In each round, they draw tokens. And so each player has an infinite pile of individual tokens, and those tokens are worth 1. There's a shared pool of tokens that's capped at 360, and they're worth 2. In every round, every player draws 60 tokens. And so here's what you obviously do in the first round. You say, well, okay, everybody just asks for 60. There's enough, right? Let's get the tokens that are worth more. And this leaves 120 tokens. Now, between rounds, this common pool regenerates by a factor of half. And so in the regeneration phase, that goes from 120 up to 180. Now, the game has two more rules that I have not yet told you about. One is if the shared pool ever gets below 30, it doesn't regenerate. And the other is if in any round, people choose more tokens, choose so many tokens that the shared pool would get to 0, the tokens in the shared pool get distributed in proportion to the request that you made. All right, and so let's just play one more game. Oh, actually, let me say this. So you can think of the shared pool. In case you have not already thought about this, let me tell you what the shared pool stands proxy for. It could be a field where farmers are grazing cattle. It could be a sea where we're fishing, or it could be an application on which many programmers work over a number of years. You can overgraze a field, or you can overfish a sea, or you can hack and hack on an app for a while, and they still give you value. But if you abuse them for too long, a time comes when they're done. They're no good to anybody. And so if you're playing this game, if you're playing a game where you care about the health of your app in an infinite number of rounds, and you trust your fellow players, when there's, after choosing 60 tokens in the first round, here's how you play round 2. You do this math. There's 180 left. Well, I can't get into the bottom 30, so I have to take those off. I'll just divide that by 4, because that's only fair. 37.5, I got to round down, so I'm going to pick 37. And sure enough, there we go. So there's 180 ready. If everybody takes 37, here I'm like having a little, let's do this. There we go. Everybody gets 37. We end up with 32. The thing regenerates. We get 48, et cetera. So you can see that cooperators, people who want the shared pool to get maintained indefinitely, rapidly devise this formula. If every player chooses this in every round, the shared pool rapidly decreases, so you only get a few in every round, but everyone is better off if you keep the pool together, if the pool survives, and so you pick what your share is every round. It totally works. All right, so remember, we did that pre-test. We separated, have 2 teams of followers and breakers. They had them play this game. Here's what happened. The groups of rule followers were 4 times more likely than rule breakers to cooperate to keep the pool alive. And in addition, it was clear when they failed because they couldn't get the math right under pressure. Right there. And they didn't let them talk, and so the rounding issue is a problem. Like if you round up, and if everybody rounds up, then you get across that 30 boundary. But they did statistical analysis on the draws that they were making, and they meant to do it. And if had they been able to communicate, they would have sustained the pool forever. The teams of rule breakers consume the common resource almost instantly. And by their choices, mathematically, you can tell they're not even trying. They are over-harvesting dramatically. It's as if during each round, their mental calculation looks like this. So one thing they measured in the study was something they call reciprocity. Sorry, I have a hard time saying that. I've been practicing all morning. Reciprocity. And it's the tendency of someone to, in the next round, do what someone else did in the prior round. And it turns out that the choices are highly reciprocal. And this is great if everyone's mats, right? If everyone's nice and we're all behaving reciprocally, then niceness has a tendency to be maintained. However, in these groups where there are players who have bad behavior, not only do they behave badly, but then they all reciprocate the bad behavior and they have this amazing race to the bottom. So this is interesting, but of more interest to us is they repeated the study and they used mixed groups. They made groups that had some rule followers and some rule breakers. And these groups behave like breaker groups. And the authors theorized that it's because of this quality of reciprocity. It's as if there's a round played where someone does that, and it just pokes everyone else in the eye, and in the next round they do this, right? Okay, buddy. They behave just like breaker groups. The breaks that have a group that's mostly rule followers that has a single rule breaker rapidly degrades to this. And so here's what the authors of the study say about this. They say that in mixed groups, this will always be true, that having one rule breaker on a team will inevitably cause it to exhaust the shared pool, and by extension, overgraze the field or overfish the sea. And I hesitate to take this analogy all the way to software development, but I sometimes wonder if I should. So they also say that the only way to avoid this problem, the only way to avoid the inevitability of mixed groups over-harvesting the resource, is to screen for rule breakers and preemptively exclude them. It's harsh, I know. Still, it's a useful analogy, and it gives me words to think about the problem of not having everybody on board on the team, and I think it will help me think about this. And so, a reprise. In light of that study, what are the consequences of my rules? Well, they still bias you towards small objects and PO rows and away from dependencies. But a willingness to follow rules, any agreed upon set of rules that are constructed to achieve a common goal, it sends a signal of willingness to collaborate. This means that you're a person who will do what it takes to maintain an application over time and round after round after round, no matter what the future holds. And as they say, rules screen for cooperative types, and these are just the types with whom we want to work. Rules matter, technically and socially. They're restrictions, right? They're restrictions. There are alarms that go off that tell you it's time to stop and think. They force you to make small objects instead of writing big procedures, and they force you to keep your business logic out of whatever framework you're using. The rules aren't fixed in stone. We don't care. I don't care what the rules are. What I want is the good thing they give you. We want cost-effective software, and I'll adopt any rule that gives me that. If you're an experienced programmer, just make your own rules. I don't care. Just make them. Any rules. The point isn't my rules, it's the belief in some rules and the willingness and self-discipline to follow them. But if you're a novice, if you don't yet have enough experience to make your own rules, follow these. Do it. It will improve your software. You can break the rules only under the supervision of a trustworthy person that has more experience. And how do you find that person? Well, they have rules. And they're sitting all around you right now, sending signals by following them. Thank you.
I know, like, first of all, you were saying about, you can break the rules if you've got valid reasons, etc. And in your book, you talk about dividing responsibilities into modules and roles, etc. And it's kind of similar to like DCI and Jim Gay's Clean Ruby book. And he talks about putting the modules inside the use case. And of course, that kind of brings your total number of class lines over 200, and it's harder to test. But his point is that kind of logic should be self-contained. So what's your kind of view? Should you have the roles separate from things that use them?
I'm kind of a hard ass about this.
Okay.
You make a module, especially if that module is only used in one class, you're just hiding some code from me that belongs in that class, and it counts against your line count.
Okay.
Sorry, just is. Should be smaller than that. If you try to solve the problem with smaller pieces and use that count against you, I think you'll like the software you get.
Okay. Thank you.
So Mats this morning talked about how he designed Ruby to give the programmer a lot of freedom, and it seems like some programming languages have sort of rules where Ruby has freedom, so a statically typed language doesn't let you change the type of something after you initialize it, but in Ruby you can do that. And I wonder, sort of like, would it be better to have a programming language that actually enforced these rules at the language level? Like, why use such a language that gives you so much freedom when you're going to then place these rules sort of on top of that freedom and sort of take your own freedom away? Would it be better to have a language that constricted you?
I hate the idea that constraints give freedom. I've always found that gets make the hair on my neck stand up whenever I hear that phrase. And I hate people giving me rules. And so I am a deeply dyed-in-the-wool, dynamically typed X small talker, and I want the freedom to do whatever I choose, whatever I think is best for my application. So I would never consider trying to enforce these as limitations on people. I initially made up these rules because I was helping out a group of people that had gone way far on the other side. So they had 1,000-line controllers, 1,500-line domain models. And so I tried to construct a set of rules that would push hard on the other side of the teeter-totter. I since found that folks found these rules useful. It's interesting to talk Caleb wherever he went. When I talked to those guys last week, they talked about how much freedom they felt by having these rules. It freed them from from making a whole class of decisions, because it just told them when they had to start thinking. And so I would never try to enforce these rules on people, but I'm willing to entertain the idea that perhaps there is some freedom in constraints, not because my personal experience is that, but because people keep telling me they're using it that way. My bias is towards small objects. I just do this naturally. In my code, there's almost nothing that doesn't meet these rules, so it feels like the right way to write code, not a limitation.